Hello everyone. My name is Kichang Choi and I'm PhD student at Yonsei University in Korea. So it's a great honor to present my research here today. So let's begin. Construction regulation checks and inspections are a crucial part of construction industry. So modern construction methods and site conditions are becoming more diverse. So regulation reviews need high expertise and is still very difficult in practice. So in Korea, the construction standard specification or KCS is divided into common, facility, and project sections, each containing hundreds of detailed codes. For example, even the temporary construction work category alone is divided into 8 main categories and 15 subcategories. So the LLMs have become a popular tool for dealing with complex document reviews, and many researchers have tried fine-tuning them for the construction domain. But recently, the trend of LLMs growing larger has been accelerating, and that means fine-tuning them is becoming more and more expensive. So the Retrieval-Augmented Generation, or RAG, has emerged as a solution that can reduce the cost problem of fine-tuning. The key idea is simple. Add an external database containing domain-specific knowledge to the standard LLM pipeline. This allows the LLM to refer to that knowledge when generating answers. Here's how it works. When a user asks a question, Lab first retrieves related document from the external database. Then it sends both the question and the retrieved document to the LLM. Using those documents, the LLM can give a more expert and accurate answer. The embedding model is a crucial part of LLM pipeline. It first turns the documents into vectors to build the external database. Then, when a question comes in, it also turns the question into a vector and finds similar documents using simple math like cosine similarity. RAG depends heavily on how well the embedding model does this job. As we always said, garbage in, garbage out. If the embedding quality is bad, the retrieved document will be wrong. And if the retrieved document is wrong, the answer from the LLM will also be wrong. So in this research, we focused on the embedding model. Instead of fine-tuning the large language model, we tried to fine-tune the embedding model, which is smaller, faster, and much more cost-efficient. Our goal was to build a Korean construction regulation RAG pipeline and can give high-quality answers by improving retrieval accuracy. Fine-tuning the embedding model requires a training dataset. An efficient dataset generation method was proposed, designed specifically for the Korean construction domain, which provides large-scale and highly structured regulatory documents. Korea construction specification documents were used as the source material. Domain-specific documents were split into individual sentences. Then entailment and contradiction sentence pairs were generated using a local LLM to ensure efficiency and scalability. This process produced the domain-specific training dataset that reflects the structure and terminology of construction documents. This slide shows an example of the dataset and training setup. The EV model, a Korean LLM with 10.8 billion parameters, was used in 8-bit quantized format to fit GPU memory constraints. The top image shows an example of the training dataset. The bottom one shows the test dataset. The test dataset consists of document question and answer pairs, where the questions and answers were generated based on the document using GPT-4o. To ensure fairness, only the quality of questions and answers was manually checked. The test dataset was not modified in any way. The embedding model was trained using multiple negative ranking loss. This is just a loss function, which pulls similar pairs closer and pushes contradictory ones apart in vector space. The CLUE model, a board-based Korean language encoder, was selected as the base embedding model for fine-tuning. After fine-tuning with the domain-specific dataset, the model showed a significant improvement in retrieval performance. Specifically, hit rate at 1 increased by more than 6% compared to OpenAI commercial embedding model. The name is text embedding C large. For evaluation, in addition to hit rate, the normalized discounted cumulative gain, the NDCG, in this table, and the mean reciprocal length, MMR, were also used as supporting metrics to evaluate retriever quality. These metrics provide a score between 0 and 1, and higher values indicate better performance. Unlike hit rate, which only checks whether the correct document is retrieved, NDCG and MMR consider multiple retrieved documents and take their ranking positions into account. This allows for a more detailed evaluation of how well the system retrieves relevant documents. In addition, we also tested how the retrieval result affected the final answer generated by LLM. Our proposed method improved the quality of final answers in the RAG pipeline. We evaluated the answer quality using two metrics, LLMs adjust and buzz score. In LLMs adjust, a language model evaluates whether the generated answer is correct. Our fine-tuned model achieved higher accuracy than OpenAI commercial model. And buzz score was used as an evaluation metric for answer quality. It compares the generated answer with the ground truth answer using a bot-based evaluation model. So this is my conclusion. This study proposed the cost-efficient approach to improve lag performance in Korean construction domain by fine-tuning the embedding model rather than LLM. The structured dataset was generated using construction specification documents and a local LLM to create entailment and contradiction pairs. The fine-tuned embedding model achieved over 6% higher hit rate at 1 compared to commercial baseline, and also improved the final answer quality. These results demonstrate that enhancing retrieval quality through domain-adapted embeddings can effectively boost lag performance without the need for heavy computational resource or fine-tuning. The main contribution is that we built a domain-specific answer generation pipeline using a simple and efficient method by fine-tuning only the embedding model. This is our extended work. We additionally applied matricial representation running to further improve performance and introduced SBE, the sentence block embedding, a chunk-based retrieval method aligned with MRL, the matricial representation running structure. For more technical detail, please refer to our preprint paper. And this is our recommendation. This means our method can utilize in other language or other domains like Vietnamese, Thai, and Arabic, or legal system, healthcare, everywhere. So if you are in the other domain, you can use this method. So this is our reference and acknowledgement. And this is my contact details. Please. Thank you. Thank you for listening.